Hey everybody, welcome to the last session on the last day. I appreciate you guys coming and checking it out. All right, so we're Ozone Storytech, and this talk is Keyframes to real-time and Ozone-Powered character journey across the animation spectrum, which is a very long-winded way of saying the ozone deformation system and characters and how different animation pipelines can take advantage of our technology. So what I'm going to cover in this talk is just a recap of what ozone is for people that don't know. Talk a little bit about the progress we've made on our authoring environment. And then we'll talk a little bit about control. And really the whole theme of today's talk is how do we give animators the control they want? How do we give riggers the tools to give animators the control they want, and how ozone helps with all that. And then we'll go into Unreal and we'll talk about our animation clip system. We'll have facial animation systems to talk about facial capture and other aspects there. We'll look at some live puppeteering. We have Dan Ortega here from the Henson Company, and we'll talk a little bit about their digital puppetry system. And then we'll look at Mocap. We've got Brian from House of Moves, and we'll talk a little bit about that. Then we'll get to Q&A and the giveaway for the Sense Labs tablet. And I should say and give a shout out to Lenovo using their ThinkPad. I think it's a ThinkPad Gen 6. So everything you're seeing here is running directly off a laptop. Okay. So let's start here. So a recap of what ozone is. So ozone is a rigging and character technology that allows you to rig your character once and animate it anywhere. So what we do is, what you're seeing here in Unreal, it's not a skeletal mesh, it's not an Alembic. This is the ozone engine driving an ozone mesh live in engine. This means for the very first time you get true interoperability. You build your character and animate it in Maya, and that's exactly the same character you're going to see in Unreal. Because we control the stack top to bottom, we also have real-time subdivision surfaces too. This is tech that we brought to market that allows you to rig that many points, but render that many points. And as you see, everything we're seeing here is running live, right in engine, right? So very, very short version of that is that's what ozone is, a deformation technology that allows you to bring kind of the highest quality deformations you'd expect in a feature animation pipeline and bring it down into engine. Okay, so we've made a lot of progress since last year. Our main focus has been taking the engine, which has been developed and really rock solid. We've worked in production to bring the UI or the interface for our tools to bring it up to that same level. So I'm really happy to announce that as of today, you can do all of your weighting, fitting, sculpting, and deployment directly in our tools right inside of Maya. So now you don't need any third-party tools to be able to use ozone other than Maya and rig your characters and then deploy them for animation. Now I want to talk a little bit about how this works, right? So what we have here is the ozone UI, and we have an ozone character here. This is Zoe. And we have our own joint solver, driving our character there. Let me go ahead and hide the joints. But what we want to look at is how will we affect or manipulate these deformers. We are shipping ozone with a full biped rig. So the rigging guys and I have a feature animation background. A lot of us worked at Pixar. We've got some DreamWorks and people that have talked and given us fed into this. But the idea is all the control you'd expect in that rig, and then we not only give you this rig as part of the ozone license, but we also teach you how to use it. Now, one thing about a feature animation rig is there's tons of options, right? There's lots of control because animators want to get really specific shapes and silhouettes in their action. So as you can see here, these are the different modules that come along with it. We've got brow module, eyes, jaw, so on and so on. And if I shift click here, it'll take a second to expand. It really shows you the amount of data, the amount of options you have when working with it, right? So this is everything that is inside a feature animation rig that you as the artist have access to. And it can be a little daunting, right, when you look at all that. So one of the first things we did is to make it easy to find the things you're looking for. So up in this search field, I can type in jaw, and immediately filters everything to do with the jaw. And if I do -A, it's going to show me only the animation channel, so the AVARs that you want to manipulate. Now here, you'll see this little yellow bar. What that means is that I already have an animation interface in play. In this case, we're using M-Gear, right? So there's an animation setup that's connected to our rig, but as a rigging artist, I don't want to have to go through my animation tool set to manipulate these channels while I'm making shapes. You want to work right in this tool that you're in, right? So here I can right click and say enable and override. And now when I move the jaw up and down, I'm doing it directly at the rig level and I'm not doing anything with the animation controls, right? Now, a big point for any studio that's looking to deploy or use Ozone is that we play nicely with all the existing animation interfaces and frameworks out there. We're just the deformers, right? So you can swap out Maya skin weights for Ozone, and your animators get exactly the same interface they're used to, all the same tools they're used to. They just get faster rigs, better quality shapes, and everything you're doing here in Maya runs exactly the same in Unreal, right? So now let's look at some of the controls that we'd want to do. So let's look at a normal situation where a rigging artist and animator are trying to figure out a jaw, right? That's what we've got here. I'm munging my jaw up and down. So Ozone is a layered system. Every deformer executes and does its own thing and passes the result up the chain. So it is not a normalized setup. And actually, this whole face rig, there's not a single joint in this face rig. Everything you're seeing here is a stack of deformers. Each deformer has its own weight map, and each deformer has its own point of control. And what does that mean? In a jaw, if I go here, I'm going to go ahead and pull out of the Ozone file the pivot of rotation for the jaw. Its control is a transform, right? Now, just to quickly sidestep, because we're a self-contained format, we need a way to basically get data out, pull it into your scene to manipulate, and then push that data back in. So think of our editor as a window into the Ozone file, right? So now what I've done is I pulled out this control, this pivot. If I go here and I open this up, you can see that we have a locator. Nope, not for there, but for here, right? So there's our pivot of rotation. Now, because Ozone is a live system, you can manipulate the point of rotation for your jaw in real time, right? Oops. And we can switch between desktops. So if I come here, right, and I mung this up and down, come on, boy. So the idea here, though, is when you're working with your animator and you're trying to figure out what a jaw feels like, normally you're rigging the character, the rigging artist does, right? And then they send that over to animation. Then animation does a whole bunch of testing. They give a whole bunch of notes, and then they give it back to the rigging artist. And you have this sort of back and forth, like a tennis match. But if I can bring the animator into the virtual office and go, hey, let's work this out, right? How does this feel when you're munging this? Where do you feel the jaw should be? And it doesn't mean that I don't have work on the rig to clean things up, but the animator and I can work this out and get the feeling of that character done. So then the rigging artist just spends time making great shapes and not worrying whether or not the animator is going to like the way the pivot of the jaw is, or how a lip moves, or how a brow moves, right? So it tightens up that feedback loop, again, giving more control faster to both your rigging artist and your animator. Now, if you don't like this and you want to get rid of it, I can come up here and I can say discard this rig fitting. So when I do this, it just tosses that away and goes back to what was the default in the rig. Right, and then I can mung this open. So you have a lot of flexibility. So the next bit here is let's talk about weight maps, right? So if I do -W, it shows me all my weighting elements. So here is the weight map for my jaw, right? Now, we have the standard weight tools, just like you would expect as a Maya artist, right? So paint weights, all of those tools really are the Maya paint tools, but we're driving weights into Ozone. We also have this tool called the mung weight tool. And this is a way of directly editing your weights. So if I come in here and I grab these points and I grab my mung tool, I can now directly edit the values. I can push and pull these points and put them exactly where I want them to be. And because we're running these maps independently, right? So like the jaw is different for the up and down than it is for the left and right. I can do things here with abandon. I can be exploring the jaw up and down. In this case, I'm going to run a smooth tool, right? So I'm going to smooth these guys out and I'm going to mung this up and down. I'm going to look at it. If it's going to let me. That's because I deselected that, right? So now I can look at this. And actually, let's turn off the weight map because at this point, you don't need to see it, right? And I can go, all right, I'm going to grab these points here, and I'm going to mung them a little further. I'm going to go here, and then we'll go through and we'll smooth these guys, right? So now I'm smoothing, pushing this out, right? So I'm able to kind of pull and push these things. So as we go through here, though, the key is I'm able to kind of push and pull. You're seeing this manipulation of the weight real time. And I'm directly editing those values, the points. So let's say I did something kind of dumb. I took these guys and I drug these all the way down here, right? So now I've made sort of a mess. But let's say that's where I want those points to be. I can now just literally walk these points into the exact shape I want them to be. Now I'm modeling with my deformers. I'm literally able to make sure that that weighted value goes exactly where I want it to be, right? And this is because each weight map is separate. Oh, look at that. Got into some weird stuff. But we can fix that, so let's go here. And I've selected that point, and now I'm going to average them. And I'm going to pull all those points down to the average, and I'm going to smooth them out, right? So this is where we can also come here and just set that weight to that or 1, right? And then I can mung it back where it needs to go. So let's smooth these guys out and move on to the next bit. So what I think is happening is because we can have crazy negative weights, which we don't normally look at here. Oh, this is awesome. You want to see how we can recover from a mistake though? I can come in here and I can mirror this over and fix it on the other side. So I was able to pull that through there. All right, we'll go through it. That point is not a friendly and happy point. So I'm going to do this, and I'm going to reopen this scene so that I don't have to look at that anymore. Sorry about that, guys. That should make the editing room floor, right, Unreal? We're not being live streamed. Oh boy, super fun. But you can also see how quickly it is to load this stuff up. Realistically, the next part I want to show you is that mirroring, right? Which I kind of showed, where you can take the weights and you can move them left and right. And then we can talk about, you know, doing a sculpt. So let's get us back to where we are, or we were. Jaw, dash A, dash fitting, dash W, dash S for sculpts. And then I'm going to do UD to show me. So I'm able to take that monster list and filter down to the things that I want to look at. So let's come here. I'm going to go ahead and enable the override here. Right, so that I can open my jaw up and down. We'll worry about the weights anymore, but well, you know, screw it. It's a demo. I'm gonna go big or go home. So select these guys, and I'll mung these weights, and we'll scoot them down, and then I'll scoot them down, and then we'll smooth, because it just looks better when I do it this way, right? And then I'll turn off my weight tool, and we'll go there. All right, so now we're back to where I was hoping to be, right? Just kind of shows this out. Let's go ahead and mirror that over. So we can move it to that. And you saw how I can go right to left, left to right. So if you make a selection on the right and you make weight maps, you can move it over. But now let's talk about sculpts. So a sculpt is our word for a blend shape, right? Now, in your traditional rigging pipeline, 20% of your work is done with joints typically, and 80% is done with blend shapes, right? You're constantly adding shapes to and it becomes this house of cards. It becomes really hard to manage. With Ozone, it's done the other way. 80% or 90% is done with deformers, and then you use 10 to 20%, you use sculpts or blend shapes to add volume, to tighten up a line. It becomes a much smaller part in the process, which means that your rigs are easier to reuse. Your animators can exaggerate things much further because you're not worried about breaking a blend shape when you do it. So with a balanced weight system and a small amount of sculpts, it gives a lot more control to your production, right? Now, if we go here, the way this works, just like we pushed and pulled out that pivot out of there, I can come in here, right? And I can say, I want to, actually, let's do this. Before I do that, let's come out of point mode here. I'm going to grab this sculpt here, and now I'm going to pull the sculpt. So what I'm going to say is, hey, I want to edit this shape. So I pull my sculpt, and what it does, it makes a copy of your mesh, and now it is straight up clean model that you can do whatever modeling you want on it, right? You can push this into ZBrush, do sculpting there, bring it back. It's just standard geometry. And then whatever you do offset-wise, so I'm going to come in here and grab this, and I'm going to do something simple. So we'll pull this through, right? And I'm going to say now, push this back in. Now, it doesn't just do a linear interpolation. When I hit push sculpt, what it's actually doing is it's figuring out how to get those points there before the actual rotation of the jaw. So when you're rotating the jaw down, the deformer, the morph deformer is executing before the rotation. So it says, in that modeling mode, I want this point to be right here. What do I have to do beforehand so that the deformer pulls it into the right place? What this means is, for free, basically, nothing on your face will move in a straight line. There's never a linear movement. There aren't multiple blend shapes in an arc. You literally put it into the shape, make it where you want, and it will organically move through. And it's just by design of the system, by executing those morphs first, And our system says you just pull it, make your modeling change, and you push it back in. Now, because these are vectors, and actually I should say because they are, I should explain what that is, right? So it's just a vector offset, math word for a position and a direction. Because it's math, because it's dealing with that, I can run the same operations I ran on my weights, and I can run it on my sculpts. So now I can smooth this out, and I'm literally smoothing the shape, the offset of that sculpt, right? If I come up here and I go to 0.5, I can multiply that amount of that vector out, right? Now imagine you're doing a shoulder and you've got everything where you want it to be, but you're not liking where it hits at the edges of the deltoid. You can select those edges and smooth them. You can take the whole sculpt and push them and multiply them bigger and smaller without having to remodel anything, right? So as I come here, do this, we'll smooth, right? All right. You know, and then let's say I don't like that. I want to go a little smaller. I can come here to 0.8 and I can multiply this down, right? And this is all, you know, as I'm moving, right? It's pulling that out. And then just like with my weight map, I can mirror it. So I'll mirror this over. And now I can say, let's make sure I'm not selecting to the model. Nope. Okay, good. Right? So I can say this here and I can go, well, let me look at it over here. Hold on. We'll grab that selection a little bit. And I'm going to bring it down again. Say, all right, cool. I don't want that. Great. And then I'm going to mirror it over from right to left. So you have a lot of flexibility how you build, work these shapes, mirror them, and run all these math operations on these sculpts because it's not a traditional blend shape workflow. It's deformers and a sculpt working together to create your shape. And each one of these is different, right? So if I look in this, so let's go back to, let's take UD out of here, all right? Now I look at here, here's the weight map for my UD. Let's come out of point mode here, right? And you know, that's what's giving me those funky shapes. But LR is that, right? Because the left and right is a completely separate thing. So let's go to my LR and I'll enable this override, right? I didn't affect this at all, right? So now, again, at control, hey, rigging artist, I want to be able to, when the jaw opens, I want to see some jowl coming in, but you don't want that jowl being pushed in your left and right. They're each individual ideas that are adding together. It's an additive system, right? Okay, let's get into some animation now, shall we? But just that's kind of where we are. The big deal here is you can now edit, manipulate, and rig all these things right inside our UI, right inside of Maya. All right, so let's come out of here, and we will open up our Unreal project. All right. And I like doing this, even though it can be messy. Like showing it really and not just a bunch of slides. It's like this is the reality of what we all do and go through with this stuff, right? So this is a shot from a short that we're working on, and this is our main character. And the big deal here is it's using our clip animation system. And what is that? It's really an alembic replacement. So if we look, you know, we're looking at a live mesh being driven by Ozone. And what this does is, or how this works is you bring the Ozone asset in with the Ozone plugin, you have a character that's ready to be animated, whether you're using control rig or whatever, and I'm going to show some examples of that. But we just can send the animation out of Maya as our own little clip format. And that clip format carries all the information you need to make the character look perfectly the same. One-to-one what you had in Maya, you can see in Unreal, right? And that clip file for an equivalent alembic is 90 to 95% smaller, because it's not carrying any of the geometry information down with it. So now your workflow coming from Maya to Unreal can be much more efficient, and you get the same exact results. And because we have real-time sub-Ds, you can make your characters lighter, which gives your artist, you know, more bandwidth to make changes. It's easier to make changes and everything else. Our first engagement, a real engagement, was with the Real Effects. They're based out of Dallas and Montreal on the show Supergiant Robot Brothers. And when they used Ozone, they never had a shot in Unreal that loaded slower than 90 seconds. It was 10 episodes, 5,000 shots, 150 characters, all Ozone, right? Now, let's take a look at this. So I'm going to bring, you know, our little Zoe character up. So another kind of piece of this, right, is because we talked about clips, right? We can send our clips down. It kind of opens up for the very first time the ability to update your animation without updating your rig, update your rig without affecting your animation, right? So let's go back to Maya here, and we'll fire up the UI again. Let's say I want to make a change to the rig, right? And I want to make this change. Again, our animator and I have worked together and we figured this thing out. We want to tweak it and we want to send it down. We can create basically a brand new Ozone file and update that Ozone file, right? So let's go here and let's do lids and I'll do -F. So we say, hey, we want to play with the lid. We want to close the lid length and make it different. So I'm going to take this projection here and I'm going to pull this fitting. Now, what is a projection? With Ozone, you can animate your weights, which means that when you think about a brow going up and down, typically it's like joint, 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 joint. You've got all these weight maps in there, and then you have all these combo sculpts. But with Ozone, it's a single slide on a curve, and you're dynamically changing that weight map to create those shapes. So it's one deformer doing the work of many, many things, right? So the lid works kind of the same way. In this case, I'm projecting that weight, like spraying it onto the surface like a flashlight, and I can change how that weight is affected. In this case, we're going to do something ugly but fun. I can come in here and I can change the projection of my lid. So let's say I do this. Again, not pretty. But now what I can do is I can say send or update this rig down into Unreal. And if I come here and replace the rig, what it's going to do is it's going to take the asset, the blueprint, it's going to replace the new Ozone file, and it's going to rebuild the layer. Or not rebuild the layer, but reload the layer. Level, not layer. And actually, that's just a short-term thing. You're not going to have to reload in 5.4 forward, you don't even have to do that. Right? So now, if you look here, she's got her little funky eye thing. Right? And if I want to fix it, I can come back here, and I'm just going to discard that fitting. So I'm going to say, hey, I want this to go back to normal. And let's go ahead and fix the jaw while we're at it. Right? So I'm going to grab the jaw weight here. We did that here weird jowly thing. So I'm just going to grab, now I am going to use Maya select through. So I'm just going to grab all of these points here. I'm going to go to the jaw LR, and I'm going to copy those weights. I'm going to go to the jaw UD, and I'm going to paste them, replace it. I'm going to grab the jaw pause sculpt, and I'm just going to clear it. And now I've wiped all that out. So I can take one wave map from one thing and move it into another. And we'll come here, and we'll update our rig. And we'll replace the rig right here. So from a pipeline standpoint, because of the way we've done our system, it makes it really easy to make these changes and do them in a way that doesn't take hours to load things, or even just long minutes, right? Anything you can do to save time saves your production money. Right? Any way you can tighten the artist feedback loop and get that to exactly what you're looking for, animators and riggers are happy, then you end up with something that's ready for animation and final animation much sooner, right? So here's our animation, it's all fixed, right? Okay, so let's look at control rig. And I'll say we're running in 5.3 right now, and we have basic control rig in 5.3. It's just kind of where we are. I'm going to show you, we can work it, you can use it, but really full control rig support is going to come in 5.5, 5.6 is when we're going to work with Epic directly to kind of finish the last little bits of that. But I do want to show you it working, because we are just deformers, right? We just take input from a joint or a slider or whatever it is. So, you know, when I go here, you know, and I grab the control rig, you know, it's driving the character. You know, everything here is working. Ouch. Yeah, you see how great of an animator I am? I'm so good at this. Sir Wade, you're much better than me. Right? So, you know, it all works. It's just that we don't have full support. We have hundreds of channels in the face, and we need a better way of picking it and managing it, making it easier for animators. So that's the plan for 5.5, 5.6. So it's working, but it's going to be a first-class experience in the upcoming version, right? Okay. So let's go up here. All right, grab that, and we will open up this. We'll see if Unreal wants to be nice to us today. The answer is maybe. We're noticing that whenever we bring up control rig here in 5.3, it will sometimes put us into a weird state. And if it doesn't pop in here in a second, we'll bounce Unreal and we'll bring it back. Being that we're the last show, on the last day, I don't feel like I'm going to be super stressed about time. You guys aren't, right? Come on, you can do it. Feel it. All right, we're going to just go ahead and nuke it. We're running into no bueno time. All right, let's bring it back up. All right. So the next thing is I'm going to show basically our standard face rig doing a hand animated facial calisthenic. And really the goal, and I'll just say it out loud as we're coming here, is to show that with our deformers and with these rigs, you do get the full control you'd expect in a feature animation kind of pipeline. All right, so we'll bring this up. And then we're going to look at some other ways that we compose it. Right? So when we think about squishy shapes, very controlled shapes, very specific shapes, everything in our rig gives your rigging artist the ability to do this. And that comes along with the ride. So not only do we give you, the tool, but we also give you the rigs. And we have a rig library that will continue to grow over time. And everything you're seeing here, we're going to teach rigging artists how to build these shapes so your animators can get these kind of performances, right? Now we've connected to MetaHuman Animator. So we've got MetaHuman Faceboard, and we've basically connected it, and we'll see if Unreal is going to be friendly to us as we bring in a control rig driven thing. Worst case, we'll bounce again. And that's the rich don't touch. Where are we? There we go. All right, so let's get out of this. Boop. All right, so what we've done is we said, hey, we're going to take the MetaHuman Faceboard and we're going to drive ozone deformers, right? So as I try to do a good job, right? And when we think about, with like feature animation type stuff, your faces are way squishier, right? You're moving things far more. And what we've said is, okay, we're going to take this mapping that everybody is familiar with, and we're putting a little translation in there to give you all the secondary and tertiary controls and big shapes you'd expect in a feature animation thing, but using the same faceboard, right? So now, and again, we'll see if this loads, otherwise I'm bouncing. By using MetaHuman Animator, aha, here's me. Check this out.
And I don't understand.
Guys, pump the volume up a little bit.
And I don't understand.
Right. So now you're seeing the kind of exaggeration you'd expect in a cartoon character, but using the same MetaHuman input, which means anything that can drive a MetaHuman Faceboard can drive an Ozone character now. Right? If I come here, same character, the Zoe character, doing the same thing.
And I don't understand.
Right? Now let's take this a step further, and I'm going to show you a character we're working on with Henson. Right? So it's not just human faces. This is Pork Chop.
I don't understand.
Though I'm told that you're not allowed to name puppets after meat. So Courtney said that won't be the name that sticks, but it's the name I've given him. Right? So what this means is, like breaking it down a little bit, is the eye rig that I used for the human rig, the mouth rig that I used for the human rig, the lip rig that I used for the human rig, I've adapted for this cartoony creature. You map that to the MetaHuman Faceboard, and now all of a sudden, you can animate using that Faceboard. You can take facial capture input like you've done before and drive it, right? Again, more control and different ways of interfacing with Ozone and whatever your animation pipeline needs to be. And you certainly can't MetaHuman Pork Chop, right? It's a different kind of beast, right? Now here, we're going to load up another example. This is a character Ruby that was designed and developed by IEL, Immersive Entertainment Laboratories. We actually did the character for them. And then we used a tool called Jolly. So Jolly Animation, or if you look up Jolly Research, they have this amazing animation tool that allows you to do hundreds and hundreds of hours of facial lip sync and dialogue, basically facial dialogue in mass, but with all the computer or human control that you would expect. So here is Jolly.
I'm Ruby, hi. And you are? Nice to meet you. You're probably wondering why I'm here.
Right. And then we ran their face system. They ran different dialogue through it.
ここに存在してるの。ここってどこ？
Ruby、子孫主義の議論はまた今度ね。
Here's that same exact script in Spanish.
Sin derretir. La última vez que sobrecargué el escáner multidimensional de esa manera fue... diga...
Right? All with the same Ozone asset. So their system, which is great for games and dealing with mass amounts of dialogue, with a layer to tune to our stuff, allowed it to connect. So hand animation, jolly animation, facial capture, metahuman animation, all being and driving our stuff. Right? So let's talk now about puppets. So we've got Dan here from Dan Ortega from the Henson Company, and we're going to show a little bit of the digital puppet system. This is not the digital puppet system. So this is me driving this character with a game controller, right? So we'll kind of pop up here, and now I'm just driving this out. And I am a lame puppeteer, and I'm going to show you a video of what the real puppeteers do, but with this character using the Henson digital puppet system. So check this out.
Hello there. My name is Steph, and I'm the cutest demon you'll ever see, and I'll be your guide on your tour through this haunted cemetery here. It's full of all sorts of unearthly horrors, and you're gonna hear them. But make sure to close your eyes. Don't see them, because the last person who actually saw one of those unearthly horrors ended up in a grave of her own. No, I'm just kidding. Hi, I'm Drew Massey, a longtime puppeteer for the Jim Henson Company, and what we have here is a small new character that was designed by the Jim Henson Company and built by Ozone Storytech for use in the Henson Performance System. The great thing about the Henson Performance System is that we can puppeteer CG characters in real time. That's what it's all about. And the goal is to get as close to Pixar level quality animation as we possibly can, but in real time, and doing all the lip sync, not with any facial motion capture or keyframing after the fact, but in real time with this here, the Henson Waldo. And this is what we use to do most facial animations. This is all the lip sync on my right hand, and then on the left hand, I have body positioning and these rocker switches under my fingers here. And as a puppeteer, I can program the system to make any one of these inputs move anything on the model, including the entire model itself.
The Jim Henson Company's core strength is creating and performing engaging characters. We are innovators in puppetry and real-time animation. We use our technology along with custom controls to bring CG characters to life through performance. With Ozone's rigging tools, it allowed us to push character deformations even further. We were able to combine multiple points of movements on the mesh non-destructively, which is super important when it comes to performing in real time. This character in particular has over 650 singular channels, so it really allows the puppeteer the ability to create more exaggerated and fun expressions.
All right. So here, let's we'll go ahead and close this out. Give some memory back to our machine here. So I'm going to open up now a direct project that has, I'm going to show you live puppeteered elements that was recorded using the Henson puppet system, driving the asset real time. So this is a separate project. Good. Don't need my controller anymore. All right, so here we go, just a little example. And then what we do is we just go through Live Link and we add a source. In this case, we have the puppet system right here. And then if I bring back up this thing and I hit play, now you're going to see all that recording there. And they have an entire pipeline built around rigging character, or not rigging character, animating characters and bringing them to life using the puppet system. At one point they had a show, I believe, Dan, you correct me if I'm wrong, but they were able to produce 10 minutes of final animation in one day of shooting. Right? Now they designed the system around that, but the idea of quick, active animation, and really, Drew is an animator. He's just a puppeteer animator, right? The same kind of things that we work with in a standard keyframe pipeline, Drew's going to be, but he's performing these things live and they're capturing them. So the system is really robust that way. But what we're going to do here, though, is I'm going to talk a little bit about how we can, let's get a good spot here. This is a good one, right? So let's say, like I said, Drew is a puppeteer, animator, and he has the same kind of information, the same feedback. So say Dan and Drew are working together to kind of figure this out. We can do the same kind of stuff we did with Zoe. So I'm going to come here and let's open up Pork Chop. And we'll talk about how we can do some of this stuff live. Same ideas. So we talked about how each deformer has its own weight map, and each weight map allow you to really custom tune specific elements of a shape or a shape in motion based on what the animator is looking for, right? Well, we can do the same thing here, but let's look at something else, right? So we'll bring up our UI. By the way, when we fire up our UI, what it's actually doing is it's going into that Ozone file and it's finding all of the control elements that you need and then presenting them into the UI. So it's every character can have its own mapping if you want, different ways of presenting and how you want to name things. So that's what it's doing when it's popping up the UI. So let's look at this. So we're going to look, I'm just going to come here. I'm going to go to the mouth and let's do the mouth avars. And I want to do UD. So the mouth main UD here, right? So if you think about this moving up and down, right? You can see how that's going. Let me do -W. We'll look at our weights. Now, I'm sure anybody that's animated or rigged, you'll get a point where you're like, I'm making this character's expression, let's say an ooh shape on a mouth. And you might want to see more of the nose move when you do an ooh, right? You want to see a different way of something moving. Well, you may want that in one direction, but you don't want it in all the rest of them, right? With a joint-based system, you have all these joints that are in there, and then there's this scaffold, there's this mechanical engineering layer underneath trying to force to fit that, and where it can't, then you're blend shaping these linear movement things on top. All of that can be ripped out. When you're using Ozone, you can say, all right, let's look at my mouth UD weight. You can see that I have a positive and a negative weight. This means I can make it look different when it moves forward than when it moves backward, and it's just built into the rig. It's a separate weight map for a different direction, right? So I'm gonna go ahead and toggle this off. And so we go here, that's positive. But let's say when we go negative here, I wanna tug the nose. So I'm gonna go and we will go here and hold the right key. And I'm just gonna add a little bit of weight to this, right? We'll go here, not hit caps lock, whoops. Boy, it just doesn't like me today. Let's go here, and among my weight, I'm gonna pull it down, right? And now when I'm moving this down, I'm tugging that nose more, right? Now let's go ahead and do something dumb. I'm gonna pull this way out here. And we talked about how you can grab these guys. Here, let's make sure I'm not selecting through the model and adding points all over the place, right? So what I'm gonna do is I'm gonna come in here and I'm just gonna tune this a little bit. I'm gonna go here, I wanna tug that a little bit here. And you can see I'm starting to add these little micro movements on the nose, right? Let's come in here, I'm gonna tug this. Say I tug this down here and we'll smooth these guys out a little bit. Pull them back up, they're moving a little too much. And let's grab all this and mirror it. So we're mirroring on the other side. So now if I go to my normal amount of movement, right? When I move down, you can see all these guys are now moving a tiny little bit. I'm adding life to my character and I didn't have to change anything about my nose rig, my jaw rig, or any of these other elements that are in there. I was able to make it move differently when it went in this direction, right? So that's one thing we can do. Let's look at playing with ranges, right? And what does that mean? So here's how it works currently. Your rigs are normalized. Typically, you're dealing with a normalized joint setup where if you have two joints and you want to make something over here adjust differently, you've got to take away from here, right? It's a subtractive system. You add a joint in the middle and you got to take away from work you've already done to add that new joint in, right? With Ozone, right, we can have different layers, so it's additive, right? It stacks them together. Our facial setups are normalized. What does this mean? That means that when my animator puts a value at 100, they get the same artistic result regardless of what character they're working with. If I'm dealing with a little creature that's this big or a gigantic Titan monster, 100 means jaw open. Brow negative 100 is brows at the eye line. We can tune that. And the way we tune that is through a separate set of channels that we call scale factors or DVARs. And so I'm going to come here and we'll do this, right? So I'm going to do, instead of mouth, let's do lid, okay? So I'm now, let's not do UD. All right. So if I look at my lid and let's go here and I'm just going to take my, I know what I'm doing wrong. I'm not really doing anything wrong. Just not making it as nice as I could, right? So now I'm looking at my left lid. So I'm going to look at my left lid. All. Where are you? Well, you can see how quick it moves even if I'm not doing it right. Oh, I know why. I want the up lid. There we go. So here is my up lid all. And let's say I want 100 to mean something different. Well, now what I can do, right, is go to my lid, do my dash D here, and these in orange are all my default values. So the animator has a value of 100, and I'm going to look at my up lid UD here, and I'm going to tune this so that it's a different value. Now what I'm doing here is changing the value that the rig drives the channel. The animator is still seeing a value of 100. What this means is rigging TDs can tune spatially and numerically, get the rigs where they feel right with the right standard normalized amount of animation control. It doesn't mean they can't exaggerate stuff. This doesn't limit the animator at all. But what it does is allows me to tune that character to the animation space where animators like to work. Then all of a sudden, libraries of animation can be reused character to character to character. You can take poses and phonemes and dialogue from one character and drop it on the next one because the animation system can get a set of controls that they're used to seeing, a normalized thing. So we flip it on the head. The animation controls are normalized and the rigs aren't. All right, so we're happy with this, at least I am. And let's go ahead and send this down the line. So now it's updating that rig and bringing it down. And we'll come here and we'll do the same thing. We'll update rig. So it's going to take that, update it, and you're going to see it reflected in the animation. Looks like we're doing good on time. Right, so now the eyes are closed different. The animation is exactly the same. I didn't change the file at all. I just changed what 100 meant on my rig. All right, so if I come back to here and I hit play, it will play the animation just like it was before. But now his eyes are closed, right? So let's go ahead and pause our animation and let's fix that. Also, I can go, hey, I don't really like the jaw where it is either, right? These are all things we can change. So here I'm going to take this and put it back to its default, which is 0.7. We'll go ahead and we'll find it and we'll kill that there. And let's look at the same idea. Let's take the jaw, because when I look at it, and actually this is important to say, Dan and Drew only had this character for like a week. Like what you saw that puppeteer is 1 week's worth of tuning. They haven't had any time to give me or work through notes to tune the character, right? So let's say I don't like the jaws moving as much as it is. So let's go in here and I'm gonna do jaw, and I'm gonna do, default values, and let's look at our AVARs too, right? So what does a 100 on the jaw look like? It looks kind of bad. So I'm gonna take this and I'm going to tune and make the jaw open in a range that makes more sense. Okay, let's look at the jaw drop. That's really far. So I'm going to go to my jaw drop and I'm going to tune this up so the jaw drop does something more reasonable, right? Let's look at our jaw forward and backward, right? That feels really heavy to me. So I can go into my forward and backward and I can tune this. Again, the animators are never going to have to worry about it. They're not going to have to change their animations. They're going to get the same sort of I know that when I do 100 plus 150 and 70, whatever it is, I expect the shape in the character. They're now going to be able to get that. Animators have more control over this. They also can now start streamlining their process and reuse work from show to show to show, which this saves money, right? Studios, like the most expensive department usually is animation because of how many animators you have. If we can save them 5% of the time, that's going to show up on your bottom line. This stuff is way better than that. I think it has the opportunity to save a lot more money. All right, so let's go that. We're cool. I'm going to update my rig. And then we'll come back here. We'll update our rig. And we're good on time. All right. Eyes are back to normal. This is a lip control, but the jaw is in range. So you can see how we can iterate through this. As we're tuning and animation, like working back and forth, it brings that feedback loop, in. Let's hit play here. All right. And now you'll notice that while the lips might be overdriven a little bit because we didn't tune those, the jaw is in a very different range now. Right? Again, we never got to this point where we could be tuning it together. And now this stuff happens really quickly, and it's a feeling thing. What does the character feel like? What does the puppeteer want to see when Drew's pulling a trigger on a control? What does he want to see there? Anyway, that is where that is. And then at the end, Dan and Brian will be coming up on stage. You guys can ask questions about all this stuff if you want. All right, so let's close this out. All right. And I'm going to close this out. And we have Mobu open. Everybody loves Mobu. Right, Brian? Everybody loves Mobu. So we're going to see if Control Week's going to let us play with this and do it right. We did a whole shoot with the IAL guys, and Brian's going to come up. Actually, Brian, why don't you come up here? So, Brian from House of Moves, you can describe your company and what you do.
Sure. Hey, everybody. My name is Brian Rausch. I'm the owner and CEO of House of Moves. What do you want me to talk about?
Motion capture.
So is that the part we're on right now?
That's right.
All right, cool. So let's see. There's how do we fit into this whole thing with Ozone? This is my 4th project with the Ozone rigs, and there's a few reasons why I love them. But I'll talk briefly about how we kind of fit into the overall kind of scope of the groups. With Henson's, they have, I'm also going to try to make this fast to try to get back some of the time that you lost with all your shenanigans.
You mean when I made mistakes?
Shenanigans.
Brian and I get along really well. If you get to
with Henson's, they do Math Party and Word Party, right? Which is, it's children's animated, not features, serialized animation, yep. And we were shooting 10 minutes a day. Now the whole thing is they want to do everything in real time, so final pixel is important to them. And because this is Henson's, right, you got to think they're doing everything to lens. So eyes like here versus here is a very big deal to them. They don't control all of that with the puppet system. Actually, they do control all of that with the puppet system, but they actually have motion capture actors in a Mocap suit. I just realized I was supposed to stand next to you while I was doing all this for camera.
I wasn't going to say nothing, man.
All right, I'm going to wander around. So we have performers in mocap suits, and where they put their head is actually controlling where the head's looking at. And if their head's up and the eyes are down, right, like it looks different, it feels different. So the real time becomes super important. What that means for us is the term I like to use, and I hope this is all getting edited.
No, we're good to go.
Yeah, okay, cool. So with the Henson's team, because it's all on the real-time side, we have to be super, super specific about real-time and super clean. So there's about an hour and a half of what I like to call stressing out really hard in the morning. Is that better?
It's fine now, man.
All right,
I might as well pull the whiskey up.
I should have asked you about that before I got up here, right?
Here's Ruby being driven by Mobu.
So this is the other side. I'll go ahead and continue talking. This is the other side. So this is a Mark Andrews project that we did with IEL. The real time is not as important on this. It's super important, but we just stood it up and pushed it through Motion Builder really quickly. Because Mark wants to go ahead and he wants to explore storyboards and make real things in real time, and he wants to knock her down the stairs, and we have to come up with different rigs and different ways that we can knock her down the stairs without throwing our performer down the stairs. So how this ties back to Ozone is because of the way that they deal with rigs, it's globalized and localized transforms that I now have more ways to interact with Ruby, and more importantly, she has been rigged in Maya, and she looks this way in Unreal, and she's going to be able to be used for film, children's serialized animation, and utilizing the same rig. So one of the things about House of Moves is we've been actually doing motion capture into Unreal since UE3. We wrote HomRender in 2010, HomRender was our compositing software, but HomStream in 2010 so that we get into UE3. And we always used to say that we were like transmedia storytelling, right? Because you could use the same character for everything. What we were doing is we were re-rigging everything every single time, once for film, once for game, once for iPad. And so we had to re-rig it all. Until now. right? That's the important part. That's what Ozone brings to all of us, is it brings the ability for us to have transmedia storytelling through a single rig that you rig once. So I'm sorry for swearing all over your video.
No, it's all right. It's all right. I knew what I was getting when I invited you up on stage.
But it's super, like, I'm a big fan of this stuff. I'm going to turn it back over to you now.
No, it's
We're good.
Okay, sit.
All right, sit.
So to his point, the character is the same, right? So that means if you're a keyframe animator or you're using Mocap plus keyframing, using Faceware, we work with them. However you want to animate your character, whatever your production needs, Ozone can be the core character in that pipeline, right? Like here is what we saw with Jolly and their animation stuff on the face, connected to and in sync with what these guys did with Mocap.
I ended up here on Earth, not here in front of you.
Right?
Although that question begs an answer.
Right? Same, here we are in Japanese.
時はね、繁殖国が足りなくなったとだ
In
け
a
言って
game,
おくわ
imagine you could localize your entire show
持ってる人は
with a
上に上
swap
げ
of
て
a
みて
thing and not have to change your rig or your
すごい
characters at all.
数。そうだ。それで
Right? Here it is in Spanish again.
Momento. Tenemos muestras para tomar. La piel de todos está sin derretir. La última vez que sobrecargué el escáner multidimensional de esa manera.
Right? I mean, so ultimately, we'll go here, because it's been trying to get me over here the whole time. The big deal is, and what I hope comes across in the talk minus the ups and downs of our presentation, is that animators and rigging artists have more control. Whatever your animation pipeline is, Ozone can be a part of it. We don't have to be all of it, but we can be a part of it. And it gives you tons of options with when you're building your characters, where you want to deploy them and how you want to animate them. This here, the Anim Revolution, is something this guy and a couple of companies and I, Dan and the Henson guys are a part of. We did this at SIGGRAPH, but we have a group of companies that have come together to show how all these different technologies kind of riding in our own lane can come together to deliver a pipeline for people. And it's really about you guys seeing that how we all can fit into a real world production, right? So if you want to check out that site, there'll be more information. And then one of our partners, Sense Labs, I have a tablet to give away to somebody here, and I have no idea how to do the giveaway. So we didn't sign anything early and whatever. I don't know what we want to do. But we're going to go through the Q&A, and then we will figure out how to give this away to one of you fine people. So anyway.
Maybe make it to where anybody who solves how to get this video on the air after me swearing, they get the...
That means the AV guys are getting the tablet.
Welcome,
anyway,
AV
Dan,
guys.
you want to come up? If you guys have any questions, please. This is the end of the talk. And go, we can get, yeah, thank you.